So we're going to take a look at how I might use fraction tiles, again the concrete model to represent a tape model, first to do addition with fractions. So we start by doing some fraction addition with like denominators. Likely it will look like this. I have one whole up and I'm going to ask my students, what happens if Jose has 1/4 of a pizza and his sister Rose has 2/4 of the pizza? I'm going to model, here's 1/4 for Rose, there's 2/4 for Rose. How much of a pizza did they eat? So students would likely be able to count right away. Jose had 1/4, his sister had 2 1/4 size pieces for a total of 1, 2, 3, 3/4. So I could do that way. I'm likely going to manipulate this several different times with different contexts. So let's look at how that might look if I'm choosing a different fractional amount. So maybe in the next story problem, I start asking students, Lisa had 2/6 of a candy bar for lunch. For dinner, she had 1/6 of a candy bar. And before bed, for her snack, she ate another 1/6 of her candy bar. How many 1/6 of the candy bar did Lisa eat? So we started with 2 at lunch, 1/4 after dinner, and then 1/6 for a snack before bed. So I can look that I have a total of 2/6, 3/6, 4/6. So I know when I do the fraction addition with my like denominators, I can really focus in on the size of the pieces, and the kids can really easily manipulate the tiles to tell the story. So how might this look if I were to do this with a tape model as a pictorial representation? Again, we've been using the whole bars and the partition bars of fraction tiles to represent concrete tape models. So how would this exact same situation roll out or look if I were to do this with a written tape model or a pictorial representation? So let's do that same story again, and we are actually going to show you different ways that students might represent their thinking on a tape model. I'm going to start first with the pretty simplistic version. So again, we know that we're talking about fourths. So I would ask kids to listen to the whole problem. Lisa had 2/6 of a candy bar at lunch. She ate another 6 of the candy bar after dinner, and then 1 more 6 of the candy bar right before bed. How many 6 did she eat? So as students are processing and thinking about that story problem, they're hearing that we're talking about the language of 6. So at this point, they know if this is the whole candy bar, they would have to partition this out into 6 equal pieces and then figure out how many of those 6 were eaten. So again, we've done some work, hopefully at this point, with like thirds. So they're going to do their very best job to approximate where the thirds would be. Once they have the thirds, they know if they do the thirds in half, I will have 6 pieces. Again, they come to this understanding by using the paper models in class and really having some time to fold and think about what they would do. So next they're going to, probably they could do some shading, or they could actually write in. So let's just assume they're going to do some shading. So here's what Lisa had at lunch. Here's what Lisa had at dinner. And here's what Lisa had before bed. So how many 1/6 size pieces? Kids could easily count 1, 2, 3, 4 and write 4, which would be a misconception. So often I would have them label the pieces as they go. So they can calculate that there are 4 6 pieces.